Well, good afternoon, everyone. My name is Thomas Roehm, and I lead the global manufacturing practice at SAS. That includes responsibilities over our manufacturing product strategy as well as our industry consulting. So this afternoon, I'll be discussing how quality and how it's managed is becoming increasingly different than it was with the traditional approaches. Also talk about how the quality imperative has changed and how big data and big analytics coming together can actually propel an organization forward in terms of how it is managing its quality. And I refer to that as customer-driven quality. And then finally, I'll touch on the technology and how SAS is approaching this. So let's begin with the fact that over the years there have been many quality programs and initiatives that have helped manufacturers in the area of quality. Beginning with areas in terms of helping them reduce their cost of quality, helping them improve their brand, and ultimately even making society safer. Now, all of these programs have contributed greatly to manufacturing, and today I would say that how it has moved forward has certainly changed the expectation of our customers. In fact, what they expected 20 years ago from a product is very different than what they expect today. But ultimately, the challenge for manufacturers still remains the same. That challenge is build a product that the consumer wants and needs, do so in a way that it's reliable and profitable. And so manufacturers dealing with those common challenges are having to address it, though, in a much different way. They're having to consider some of the very new data sources that they have to deal with. Now, the cost of poor quality, quite frankly, hasn't changed much over the years. Now, there's been incremental changes in how quality costs have been driven down, but then new advents and expectations rise it up again. And so across all manufacturers, on average, the cost of quality is about 20% of their sales revenue. 20%. That's pretty significant. That goes right to the bottom line. And small increments of changes can certainly make a significant impact. In fact, moving up one sigma level can have an impact of anywhere from 20 to 40 to $50 million. Now, when I consider the cost of poor quality, I tend to put it into four different buckets. The first one being underutilization. And underutilization is a result of planned overcapacity for an expectation that our yields are going to be low, that we're going to have some quality issue associated with those, or some number of products that aren't going to make it through the process. And this contributes from a cost perspective in both in terms of the asset utilization and the depreciation on that asset, the maintenance on that asset, because again, it's having to be worked more often, but also in the fact that things then begin to bleed out into that next bucket, which is scrap and rework. Now, scrap and rework contributes about 6% to the overall costs of goods sold associated with sales revenue. And I think it's probably a pretty well-known adage that identifying and fixing a defect early in the process in the production facility is about 5 times actually cheaper than it is when it gets out into the field. Which then leads into the next bucket, which is warranty costs. So warranty costs, again, on average, are about 2 to 3% of sales revenue for a manufacturer. Now, warranty costs consists of administration costs, it consists of the parts, of the service technician, and those are the costs that are internally felt within the organization. But there's that cost to the customer as well. And that cost translates typically into inconvenience of the fact that they have to take their vehicle in for service, or that their smartphone is not working and they have to go back to the service provider to repair that. Which then leads into the next bucket, which is lost sales. Lost revenue associated with the fact that your consumers have gone to another brand, right? Or that you're carrying excess inventory because of that. So the journey that companies have been on, implementing a number of quality programs, has certainly yielded, and has been fruitful. It's yielded benefits. But it's also a pretty known fact that the cost of quality is still very significant. So this is this chart represents a study that IDC did late last year where they surveyed manufacturers. And one of the questions that they asked was what was your top investment priorities for 2014? And I find it interesting that quality management is in the top two. Now, with all of the programs and initiatives, why is that the number 2 item? Is there not enough technology out there addressing quality today? And I think the answer to that question really lies in how is quality changing? Right? And that's what we're going to discuss a bit more today. So how has quality changed? Let's start from the very traditional view of quality. A very inside-out perspective, right? Very much has to do with things like specifications and tolerance levels, being able to measure a very objective standard and perspective to the product itself. But I think what's changing is an inclusion of not just the objective measures, but more of the subjective measures as well. And particularly the customer's perception of that product and the value in which they receive from that product. Right? Now, in today's day and age, the consumer has so much access to information. And in fact, their opinion may not even be correct. But the point is that it's an opinion, it's a perspective, it's their perception of the product. And that needs to be considered into the quality process as well. So again, very different, I think, than how it was thought of in past years. In fact, a couple facts associated with customers' perception. Let me just start with the first one. 91% of unhappy customers will never purchase from that company again. Okay, that's been a survey and a study that's been done. Consumers are pretty vocal about that. Also, within that same study, they talk about the fact that consumers will tell 10 other people about that unhappy experience. And that was before the advent of social media. Social media now magnifies it or amplifies that to the hundreds. And from a safety perspective, nobody wants a safety issue. Nobody wants, vehicle problems or laptops that blow up or any issues with reflective of that. And of course, it's impactful to society, but it can completely destroy a brand and hurt a company very badly. And what's changed is the access to information that consumers have today. We know that with a click of a mouse, we can all go in and we can read peer reviews, we can read professional reviews, we can go to consumer insight comparisons, we can even oftentimes go to government sites and receive information about products. Not just the products that we're interested in, but the competitors' products as well. And really down to some of the very specific features and attributes associated with this. And this dynamic, I think, is really driving how companies are going to have to look at quality. Again, both on the objective and subjective perspective. Now, Gartner, the analyst firm, did a study, a gentleman named Simon Jacobson, and he's talking about quality, and I really like what he's saying here, which is information is the oil of the 21st century. And he suggests that from a quality perspective, the way it's used to support that has to change. Okay? there's a lot of data that's out there that isn't being leveraged. And he further goes on to talk a little bit about the challenges. And what he's suggesting is that organizations cannot get to the oil. Okay? They can't get to the data, they can't get to the information. And one of the key reasons that this is in place is because of all of the data silos. I mean, this chart here just represents many of the systems that you'll probably recognize probably within your manufacturing facilities. The manufacturing execution systems and the SCADA systems and the LIMS systems and the ERP systems, all of them collecting data, okay? Oftentimes data sitting in storage or maybe being offloaded because it's too expensive to maintain and store that data. But most importantly, the challenge is associated with getting the signal from all of the noise in all of that data. The volumes and the variety, the types of data, and the velocity to which that data is coming in is tremendous. And that's the challenge that organizations have, is how do I get a hold of all that? And in fact, he also talks in his study that engineers typically spend about 80% of their time trying to bring the data, find the data, access and integrate it to do root cause analysis and to do problem solving around that. Okay? That's not a very effective use of an engineer's time. So if I could take his analogy of the oil, I would then call, with respect to quality, that voice of quality is the oil. And I'd break it down into three different buckets. The first one being voice of the process. Now, voice of the process is a very traditional view of manufacturing quality. It's looking at data that's coming from the process systems, the data historians, the SCADA systems, the manufacturing execution systems. And if you think about those systems that are there today, they are becoming smarter. They are collecting more data. Okay? There's more information to be gleaned from all of that. But with all of the automation that's being implemented, there's also much more subtle ways in which quality can be compromised. And it really takes looking at the data and understanding the data to be able to glean the signals out of that to understand if you really are having a potential issue within the process. If I move over to the second one, voice of the product. Voice of the product includes things like manufacturing inspections. It would include warranty claims. It would include diagnostic systems and embedded sensors that sit within the product themselves. And in fact, again, another very traditional view of quality, but what's very different today is the amount of data that is being produced. Again, smart machines and sensors on machines are streaming information to us or to the manufacturer, potentially. Okay? If you think about an automobile, what was the thing I heard? A terabyte an hour of information that it's collecting and potentially could be generating to provide some useful diagnostics and for useful information. And this last one, voice of the customer. This is really a growing and newer area. Now, traditionally, voice of the customer came from customer surveys, whether it be a survey that you're running or maybe it's an external one like a J.D. Power or some other external factor that's running surveys. But today, it's much more than that. It's all of the textual data and comments that sit within the call center records, that sit within technician notes, the things that they've written about what they saw when they were out there. It's in blogs, it's in Twitter accounts and Facebook accounts, it's in consumer enthusiasts or product enthusiast accounts. It's also sitting in government databases. The government oftentimes, not all governments, but many governments begin to collect information about the products and product safety themselves. Very, very rich and unstructured data. Okay? A lot of textual data in there that can be brought together. And I think what's concerning to a point is that because of how this has all evolved, each of these areas are typically owned by a different part of the organization and further promoting the silo that I mentioned earlier. Voice of the process, typically owned by the manufacturing part of the organization. Voice of the product, oftentimes by the service or warranty group. And then voice of the customer, oftentimes owned by marketing. And each of these organizations have specific metrics that they're looking at in ways in which they analyze the data that may or may not be relevant to the other parts of the organization. And in fact, many organizations, if I'm in the marketing organization and I want to get some production metrics, it's very difficult to do that. I have to go through the production group. And what are they looking at? They're looking at first-time yields and defects per million and a number of other metrics that may not be as relevant to the marketing, but that same data could be used to provide useful information to them, just in a different way in which it's described. So today, companies really need to treat quality a bit differently. And that's what I'm suggesting here. That it has to be more of an enterprise view, that it has to go from the boardroom to the shop floor. It has to include suppliers. It has to include marketers. And those aren't necessarily new concepts and things that people have strived to do. It's just been very difficult to do that because of the way our technology has evolved. But organizations really need to begin to eliminate some of these data silos. And they do need to do so in a way that helps organize all of this data. I mean, it really is a big data problem. You know, if anything personifies big data, in my opinion, it's quality. Okay? We're talking social data, machine data, inspection data, survey data. It just continues to get broader and broader. Okay? And how do you again organize all of that so that you can get that signal out of all of that noise? Now, when I talk about big data in the quality area and then applying analytics to it, and then being able to view that from an enterprise level and allow organizations to consume that information and consume that data in a way that would be useful and productive for them, that's what I'm referring to when I use the word customer-driven quality. That is a term that we have come up with. It's not an industry term yet, but it's a new term to look at quality in that holistic view. And so what I'd like to do is walk through each of these areas and provide you some tangible examples of how big data and analytics are coming together to provide valuable return on investment for manufacturers. So this first example that I'm going to walk through is in the area of improving yield, reducing scrap and rework, and it's focused very much on the production performance area. So again, what's important to a production engineer? It's to have the ability of information integrated and accessible to help make decisions to improve how the production facility is performing, improve the quality and the first-time yield of what's going on within those. So machine data, diagnostic data, all of that coming together, and then being able to apply analytics, advanced analytics, to do predictive modeling, to predict the yield or the potential reduction of a poor batch, for example, and then being able to provide alerts to that information. And then being able to have a production or quality engineer go in and very rapidly be able to pull that information together and start the root cause analysis cycle, right? So effectively reducing the time to detection and then the time to definition and the time to resolution. That's what we're trying to reduce, okay? So we can improve the overall quality. So let me give you a couple examples. The first example I'm going to share with you is a company named First Solar. They make solar panels. And so they are collecting information from the solar panels that have been deployed out into the marketplace. So they have sensors on these, so they're pulling information in from there. They're pulling information in from their production facility when they're producing them. They're also looking at other environmental data elements that they brought together. And essentially what they're able to do is be able to model and predict potential quality issues that they have. And so they have built a number of models that provide them an alert, and then they have a root cause analysis system that allows them to go in and then go through that issue resolution definition process. As a result, I mean, within their first year of implementing such an analytic big data solution, they were able to reduce by $200 million US their reliability related costs. Okay. I'll share with you a second example. This is in the semiconductor industry, and this is Altus Semiconductor. And so, again, very common a challenge, a lot of data sitting in disparate systems, data about the production process, about the actual raw materials that were coming in to their facility, and as well as electrical data within the plant facility as well. And so they deployed, they were able to model and manage and deploy predictive analytics in a way that they had both standard analytics, and when I say standard analytics, they're applying very standard techniques from an analytic perspective, things like regression analysis, multivariate, or an analysis of variance, and deploy and manage those to different process steps. But also, they created a number of their own proprietary models. So their data scientists went in and maybe started with a standard model, but then deviated from that to be very specific to their business operation. Okay, so they manage both of these models in that environment. And so, the result is not only are they able to accelerate their analysis cycle time, but more importantly, they've been able to improve yield. Let's move down into the asset performance area. And again, when you think about assets in the production facility, these could be the robots, these could be different machines, pumps, different things within the process steps. And those machines themselves have quite an impact on the manufacturing quality as well. And these machines, today with all the sensor technology that's out there and the smart devices that exist within some of these machines, tremendous amount of information. And what can be gleaned from that information? You can build predictive models to determine, is that asset running at the right level of utilization? If they were able to schedule the maintenance, it took them 18 days. So able to reduce that by 20 days. That's quite significant when you're talking about millions of lost revenue dollars every day. This particular company, in fact, has done this. They've gone into production, and they've been very effective. In fact, they've only had one unscheduled maintenance in the last 2 years. Prior to that, they would run about 10 to 12 a year of unscheduled maintenance. So very significant return on investment. The second example I'll share with you is a global healthcare manufacturer who manufactures, amongst many things, MRI machines. And this company, what they've been able to do is they were looking to improve their equipment downtime. They wanted to lower their cost of service. So these are, once they've built the MRI machine, they then deploy it into a hospital. It's sitting in the different hospitals, and as you can imagine, it's very important. It's a revenue generator for the hospitals, but the equipment manufacturer offers a service contract and essentially guarantees a certain level of uptime. And so to adhere to that and be able to minimize their risk and exposure, they have built predictive models. And these predictive models essentially are looking at all of these devices. There's 15,000 of them deployed under the service contract. And each of these things are generating 20,000 event codes a day. Now, an event code is when a machine, one of these MRI machines, it's the velocity and rate to which it turns, and when it's turned on or off, or what state it's in terms of the imaging. They also have sensors that are looking at things like temperature readings and other metrics associated with that. All of this information comes together, and they've built predictive models, thousands of these models in which they're managing and deploying. And what they've been able to do with this is that whenever this thing predicts that one of these might fail, it sends an alert out to their remote diagnostic center. They then evaluate that. They do some remote evaluation to it, and if there's a repair or service that needs to take place, they do so and dispatch a technician. What have they been able to accomplish? They're able to identify 5 to 10 days prior to it failing, so they can be very proactive, ensuring that they get the right parts and the service technician out there. They have a 70% accuracy, so 70% of the time there is no failure that they don't know about 5 to 10 days prior, and there's only 20% false alarms. So a false alarm is something came into the queue, they did a remote review of that, and they determined there was not an issue, they did not send a technician. So again, help to lower their risk and lower their cost of service. Let's move into the field performance area. And in the field performance, again, if you remember what we talked about earlier, we're talking a bit about warranty claims and call center, things that happen once it gets out into the field. And here, it's important to marry together not just the service record, the warranty claim, if you will, but together with the customer data and the production data. When was it produced? How was it produced? What's the bill of material? And again, marrying that information. And when you do that, again, you can deploy analytic models to all of this data as it's coming in to evaluate it and provide that early warning that's potentially there's an issue in the field. And again, identifying an issue earlier gets me on the path to issue detection, to root cause analysis and resolution. A couple examples I'll share here. This first one is Volvo. This is Volvo truck. Now Volvo truck consists of Renault truck, it consists of Mack truck, and Volvo truck and their bus areas as well. And I want to share with you a quote from the project that they put in here. So this is from their director of product quality for EMEA, so Europe, Middle East, and Africa. What we sell are not trucks, but rather transport solutions to enable our customers to offer the best logistical services to their end customers. So a bit of a different perspective in terms of product quality. They're looking more for providing a service, an uptime, an availability to their consumers, but doing so by managing this information and this data. In fact, they go on to say that Volvo is striving for 100% availability of its vehicles. Okay. So how are they doing this? Again, they're bringing all of this big data together, including information from the trucks themselves. So the trucks are collecting data. And they do that in a system they call QRaft, which is an analytical solution, bringing data and analytics together to, again, very typical of what I'm talking about, predictive modeling, analytic modeling, root cause analysis, being very proactive and efficient. Another example in the field performance data is with a company called General Motors Shanghai GM. They have put in, again, an analytic field quality type solution, bringing together these elements that I've described, both warranty claims, customer data, and product data, applying analytics to that. And as a result, they were able to reduce their cycle time of detection by 3 months. So from when products started going out into the field until they got a clear signal that there was an issue, that reduction was 3 months from their typical methods. Now, typical methods for warranty analysis are usually top 10 lists or top 100 lists where people focus on the top items. But oftentimes you miss things that are growing and beginning to move in their way up that contribute heavily to customer dissatisfaction and cost of quality. Okay. Not only were they able to reduce that by 3 months, but they had a 34% reduction per vehicle in warranty costs. The last area I'd like to touch on here is customer perception. So spent a little bit of time early in our discussion talking about the consumer and how they view, or their perception of quality is almost more important than what the quality actually is. And so this becomes almost an early in some cases, maybe the earliest indicator of once a product is out into the marketplace into a potential issue that you might have. Okay? So being able to mine and organize social media and blogs and enthusiasts and government sites and call center logs and be able to bring that together in a way that it can be an early detection for you. And to do that, it's also very different than maybe the marketers look at social media. You know, they're oftentimes looking at what are people saying about my products. You know, do they like it? What's the sentiment about it? You know, what do they think of my brand? Very important questions. But from a quality perspective, you want to be able to break that down a bit lower. You want to get it down to even some of the component levels if you can. And so having a taxonomy that you organize this information in that then maps across the rest of the areas within the quality chain is very, very important. So I'll share with you a couple examples here. The first one is a automotive company. And this automotive company is bringing together call center records. They are bringing together social media, so they're looking at Twitter and Facebook. But they're also looking at, in the US, they have what's called the National Highway Transportation Association. It's a government agency that collects all safety and vehicle repair information, and they maintain and manage all of that. Right, well, that's public domain. In fact, lawyers, believe it or not, have access to this information. So US lawyers go in and look for ways in which they can maybe represent a lawsuit. Okay? But they bring that information together as well so that they have proactive information and they organize it in a way that helps them to detect perceptual issues. Again, real or not real. Even those that aren't real, they may have to do some type of a marketing program to help consumers better understand a feature or function. The second example I'll share with you is very recent. This is Lenovo, the computer manufacturer. And what Lenovo is doing is they're bringing together call center data, product review sites, social media, and community forums, people that are out there talking about computers and PCs and what they like and don't like about that. And they bring that together and they apply text analytics to that information. They perform what's sentiment analysis to be able to measure the likes and dislikes of certain features and functions, and also content categorization to organize it in a way that the context of how it's being written is meaningful. Now, we probably are all can appreciate the fact that there's a lot of things that are said on social media that are incorrect. In fact, if you could apply a lie detector to social media, that would be very useful in terms of as a company trying to use that information. Well, in fact, that's what they've done. They've used some of the analytic capabilities to score information as it's coming in and be able to ascertain, is that a truthful comment or a non-truthful comment, and what value can I put to that? All of it is useful, but some of it needs to be organized and gleaned and viewed in a different way. And so that's what they're doing with that. And they're able to then provide this information to their quality engineers, to the marketing department, to the manufacturing facilities, so all of them have access to this. Again, striving more towards an enterprise view of quality. So I've shared a few examples about how big data and big analytics have come together in the areas of asset performance, production performance, field performance, and customer perception. And this holistic approach is what I believe is really that next step on that quality journey. Now, technology certainly plays a role. It's a piece of the puzzle. It's not the only piece, but it is a piece, particularly when you're talking about big data. Right? Without technology to harness all of that, it's just too much. And so an analytic platform for quality, I think, is an essential component. An analytic platform that can represent and understand structured data, unstructured data, can handle streaming data. So it essentially is responsive to the volumes, the variety, and the velocity to which data is coming in. And the veracity, the truthfulness of that information as well. And so one of the things that we've really been driving at SAS is a product strategy that can help enable such an approach. And so in doing that, we establish a very simple foundation. We want to help companies be able to answer these 4 questions. How are my products performing? How is my service operations performing? What's likely to happen? So be predictive, provide that future insight. What and why did something happen? So be able to quickly get to that issue resolution. And then lastly, has this ever happened before? And what can I learn from my past events? Okay. So 4 pretty simple questions. And being able to do that across all of these different data types. Okay. So today, and in the past at SAS, we have provided analytic solutions for each of the 4 areas that I've talked about so far. So we have a solution for warranty and looks at your warranty data and has patented analytic algorithms to do early detection. We have the ability to handle sensor data in our asset performance solution. But what we're going to be releasing in July, and you're one of the first groups to hear about it in a public forum, is a new analytics suite. It's our quality analytics suite that consists of 4 core modules: field quality, looking at everything on the field side; asset performance analytics, looking at everything about the assets themselves; production quality, looking at the floor, the manufacturing floor; and then perceptual quality, looking more at sentiment, social media, more the textual side of it. And then being able to have a data management layer that helps bring this information together, and then a standard set of workbenches. And these standard set of workbenches make it presentable and consumable for all parts of the organization. So if I'm the executive, there's a certain level of information that I want to get to. If I'm the manager of a particular area, maybe it's the production manager themselves, there's certain information that I need to be able to get to the data scientist who's going to do modeling. And there's a couple roles in between all of that as well. So through this approach in standard workbenches, you have one alerts module. You go to one area to see all of your alerts and be able to manage those alerts through corrective action into a knowledge base. Here's what we did with it, here's how it was resolved, and that knowledge base is then searchable. Okay? Being able to build, deploy, and manage models across all of these different areas. Okay? It's what I believe, it's the new competitive paradigm in quality, and what I think can help companies then achieve customer-driven quality. Thanks.